In this video, I'm going to show you how to write ion formation equations. These are chemical equations that show how an atom turns into an ion. So for the first example, we're going to talk about how a atom becomes an anion. An anion is a negative charged ion. For example, we might have nitrogen 3- or oxygen 2-, or chlorine 1-. Those are all examples of anions, atoms that have gained electrons to become a negatively charged ion. This is what nonmetals do. So a nonmetal atom gains electrons to become an anion. Here's an example of one. We can take fluorine, for example. The atom fluorine can gain 1 electron and turn into the F- ion. In these ion formation equations, you'll always notice that the neutral atom goes on the left side of the equation. So it always goes on the reactant side, whereas the ion always goes on the product side. Let's look at another example. We can look at the element oxygen. So oxygen has 8 protons in its nucleus. It has 2 electrons on the first level and then 6 on the second level, for a total of 8 electrons. So this atom, oxygen, has 8 protons and 8 electrons. In this outer energy level, it has 6 valence electrons, but it wants to have 8. So it's going to gain 2 more electrons. So we're going to add 2 electrons to it. So we could add another electron. We could say it's going to add 2 more electrons. Then it will turn into an oxygen ion, which still has 8 protons. It still has 2 electrons in the first level, but this time in the second level, instead of having these 6 electrons, we're going to show that it has gained the 2 electrons for a total of 8 valence electrons now. So this is the oxygen ion now. And it's an ion because it's charged. It still has 8 protons, but now instead of 8 electrons, it has 10, right? Because we added 2. We added these 2 right here, got added onto that atom. So instead of having 8 electrons, now it has 10. So if we look over here, remember the protons are positive charges and the electrons are negative. So now we have 8 positives and 10 negatives. So we would give this a symbol for oxygen of O2-, meaning it has this up here in the upper right corner is its charge. It has 2 more negative charges than positives. So we say it's an O2-, or oxide ion. If we were writing the ion formation equation, instead of doing it with all these drawings up here like this and this, we just put it in symbols. So we say O for the oxygen atom plus these 2 electrons right here we symbolize as 2E, and we put our arrow, which means turns into products, and then we put the oxygen ion with its charge, O2-. So the ion formation equation is just this thing right here, which shows that an oxygen atom gains 2 electrons and turns into an oxygen ion. Since this ion is negative, we call it an anion. Let's look at an example where we have an atom forming a cation. So a cation is a positive ion. Positive ion. And this is what metals do this. This is what metals do. Metals lose electrons and form cations. So we might use an example like sodium. So a sodium atom has 11 protons in its nucleus, and it has 11 electrons in its energy levels. So there's 2 in the first level. Here's 8 in the second level. That's a total of 10 electrons. But sodium has 11 electrons, so we got to put one more in this outer level. So since this is sodium atom, it has 11 protons and 11 electrons. I'm getting this from its position on the periodic table, right? And out here in its outer energy level, it only has 1 electron, so it has 1 valence electron. But it wants to have 8, so it's going to end up losing this electron right here. It will lose that electron. And what it will turn into then is a sodium ion. So the sodium ion will still have 11 protons. We'll still have 2 electrons in the first level, but it will have 8 in the second level just like it did before, but it won't have this level out here because that electron that was there is now no longer part of this atom. Instead it lost that electron. So I'm going to erase this whole level. But if there's not an electron there, there's no energy level. But where did this electron go? It didn't just disappear from the universe. What we ended up making was a sodium ion with 11 protons still. But now it only has 10 electrons. But that electron didn't go missing. It's just right over here. It's just no longer part of the atom anymore. So it's kind of like we took this atom right here, we removed an electron, so it turned into an ion, and now we have a free floating electron. And what I mean by that is it's just not part of the atom anymore. Maybe another atom would come and take this electron and accept it into its outer energy level, like the non-metal example that we just showed, where oxygen gained 2 electrons. This is how they might get an electron from a metal atom that gives it away. Now, if we were going to write an ion formation equation to represent what we just saw here with sodium turning into sodium ion, we don't have to draw all these big drawings and make it all take a real long time to do. We can symbolize this, right? All we have to do is write the sodium atom symbol and then an arrow going to the right, turning into sodium 1+ ion, right? Because it's got 11 protons, which are the positives, and only 10 electrons now. So it's got an extra positive charge. And we have to put in on the product side, because we produce the ion and 1 electron. So again, we started with the atom, and we produced an ion and 1 free electron. So the answer to writing an ion formation for the metal, it's just this right here. All those drawings, I was just trying to illustrate where the electron's going and why it goes onto the product side. If we flip back and look at the previous example with oxygen, notice that I still have the atom on the left side, the ion on the right side of the arrow, but I had the electrons on the left side, because in a non-metal, it's going to gain electrons onto that level. So we're going to take the atom and add electrons to it. So the electrons are part of the reactant. But on the metals, we're actually taking this electron away from the atom. So we end up with an ion and a free electron. So our equation is this. It looks like the same. It has the atom on the left side, ion on the right, but what's different is the electrons have been written as a product because we're producing an ion and one free electron. It's no longer part of the atom. Let's do another example for sulfur. All right. So we want to show how sulfur atom turns into sulfur ion. So what I have to do there is put the symbol S, and then the arrow. Over here I got to put the symbol for the sulfur ion, which is S2-. And the question is, where do the electrons go? Do I put +2 electrons over here, or do I put +2 electrons over here? And since sulfur is a non-metal, remember non-metals are going to gain electrons. So we're going to take the atom here, this is the atom symbol because there's no charge on it, and we're going to add electrons to it. So the electrons go on the reactant side and not on the product side. So this would be our answer right here. And again, we've got the atom on the left side, and we've got the ion on the right side. Let's do one more example with a metal. How about calcium? We put the atom symbol on the left, we put the ion symbol on the right, and the question is, where do the electrons go? We have the +2e on the left side, or +2e on the right side. And since calcium is a metal, we know that metals lose electrons. So this atom here has to lose electrons. Normally calcium has 20 electrons, but it's going to lose 2 of those electrons and end up making an ion and 2 free electrons. This ion will have 18 electrons over here, and it will produce 2 free electrons that used to be part of the atom but no longer are. So the electrons do not go on the reactant side with the metals, they go on the product side. So our answer will end up being this. So we always have an atom on the left side, we always have an ion on the right side, but what is different is where the electrons go. And they always go on the right side for metals, but they always go on the left side for non-metals. And that's how you do an ion formation equation.